In this video, I'm going to show you how to use the alligation method when you have 4 components, and we are starting right now. Hello, this is Dr. Dankwa, and if this is your first time here and you'd like to learn pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. So let's get right to it. So in this video, I'm going to show you how to use the alligation method when you are mixing 4 components with different concentrations to make a final product of a specified or a desired concentration. Now, if you're looking for videos where you're mixing 2 components or mixing 3 components using the alligation method, then I'm going to put links in the description and I'm going to link it in the cards as well. But let's get right to it. Here's a good example to illustrate how to use the alligation method for 4 components with different concentrations. And now the question says, in what proportions may a manufacturing pharmacist mix 20%, 15%, 5%, and 3% zinc oxide ointments to produce a 10% ointment? So in this question, the desired concentration is 10%, and you're mixing a 20, 15, 5, and 3% zinc oxide ointments. Now, it's important to recall that when it comes to the alligation method, your desired concentration must always be between the concentrations that you're mixing. So here, because you have 4 components, this would be a really elegant way to set it up. You use your alligation grid, so you have your 2 vertical lines. Now you're going to have 4 horizontal lines, and you're going to arrange your concentrations on the left-hand side as follows. So because your 20 is your highest concentration, that will go to the top left. And then right beneath it, you're going to have your 15%, and then your 5%, and then your 3%. And so now, because your 10% is your desired concentration, that's going to go in the middle right here. And there are 2 ways you can actually set this up because of how the concentrations align. So the first one is to do it exactly this way, where you have your 15 and 5, you mix that one first, and then you go ahead and mix the 20 and then the 3. And that's one way to actually have your proportions. So in this instance, the way that will work is as follows. You're going to take the 10 and you're going to subtract 5 from that. So 10 minus 5 is 5, and that will go right here. And that will represent the parts of the 15%. So you have 5 parts of the 15% ointment. Now you're also going to take the 10 and subtract that from the 15. So 15 minus 10, that gives you 5, and the 5 goes right here. And that represents the parts of the 5%. So you also have 5 parts of the 5% ointment. And then now you're going to do the outermost section. So you're going to do the 20, the 3, and then the 10. So what that will look like is you're going to take the 10 and you're going to subtract the 3 from it. So 3 from 10 gives you 7, and that goes to the top right. So you have 7 parts of the 20% ointment. And you're going to take the 10, subtract that from the 20, and 10 from 20 is going to be 10. So you have 10 parts of the 3% ointment. So one way to process what is going on right here for the 4 component system is as though you are using the alligation method for 2 components, but you are doing it twice in this setup. So you take the 15 and the 5 and then the 10, and then you do the 20, the 10, and then the 3. And that gives you this setup right here. So in terms of the proportions, I'm going to put right here the 20% is to 15% is to 5% is to 3%. And beneath, I'm going to put the parts. So you're going to have 7 parts of the 20%, 5 parts of the 15%, 5 parts of the 5%, and 10 parts of the 3%. So that's the proportions in which you need to mix these components. Now, one way to extend the thought process here is to assume you have a total quantity. If you did have a total quantity of this ointment, then what you will need to do is you need to add up all of these individual parts to give you the total parts. And then you find the actual amounts of each of the concentrations by taking the parts that are represented divided by the total to give you the quantity. So let's actually use an example. So let's actually assume we wanted to make 270 grams of the 10% ointment. So we need to find the total parts. So total parts is going to be equal to 7 plus 5 plus 5 plus 10. That's going to be equal to 27 parts. That's the total parts. Now, if you wanted to find out how much of the 20% we need to make the 270 grams, then what that will mean is you take the parts that represent that, which is 7. So 7 divided by the total, which is 27, times the quantity that you need to make, which is 270 grams. that gives you 10. So you need 70 grams of the 20% ointment. Now, this portion is not actually in the question. I was just trying to extend the thought to enhance the understanding. Now, that's one setup, and because of how the concentrations are presented, you could actually set it up slightly differently using this approach, and both of them will be correct. So once again, we're going to set up the alligation grid. We have our 2 vertical lines, and then we have 4 horizontal lines. And once again, on the top left, you're going to have your 20, the 15, the 5, and then the 3, and your 10 goes right here in the middle. And that's because if you notice, it's between, your 10 is more than 5 and 3, and it's less than 15 and 20. So it stays between those two numbers. So now here, what you can do is you're going to take the 15, the 10, and then the 3 as the first set. And then subsequently, we will do the 20, the 10, and then the 5. So for the first set, you're going to take the 10, subtract from that the 3, and you're going to end up with 7. And that is 7 parts of the 15%. And then you do the 10, subtract that from 15, that gives you 5. And so you have 5 parts of the 3% ointment. So that'll be the first pair. And now the next set will be the 20, the 10, and then the 5. So if you subtract 5 from 10, that gives you 5, and that gives you the number of parts of the 20%. So you have 5 parts of the 20%. And then you will do the 10 and then the 20. So 10 from 20 is 10. That gives you 10 parts of the 5% ointment. And so now in terms of proportion of the 20%, the 15%, the 5%, and then the 3% ointments, you're going to have 5 parts of the 20%, 7 parts of the 15%, 10 parts of the 5%, and 5 parts of the 3%. And if you mixed everything in these proportions, you would end up with the 10% ointment. Now let's talk about one way you can check or confirm your computation. And what you do is you will take the concentrations of the components you are mixing. So that's 20%, 15%, 5%, and then the 3%. And then you multiply all of these by their respective parts. So for the 20, we have 5 parts. For the 15, you have 7. For the 5%, you have 10 parts, and for the 3%, you have 5 parts. And now this is going to give you 100. This gives you 105. This gives you 50, and this gives you 15. And so when you do the totals, now the total parts here is going to be 27. And then the total that you're getting from multiplying the concentration and the number of parts is 270. And so if you divide this value by the number of parts, it should give you the concentration that you desire. And if you don't get the answer, that means there's something wrong with your analysis. And so here we see that if we take the 270 and divide that by the 27, that gives you 10. And that's actually the concentration that we desire in our final product. So I hope you found this video tutorial useful. If you did, be sure to like it and share it. And if you have any questions, leave them in the comment section and I'll get to them as soon as I see them. If you'd like to learn more pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the notification bell so you don't miss anything. Thank you so much for watching, and I'll see you in the next video.